We were learning about the event queue, but so far we have only looked at the call stack and the execution context and something about the message queue. And so far we have seen that the message queue in our example so far would only have one task, which would be the entire global context, which would be given in. And this global context would actually call other context, execution context, and the code would be executed, right? So now let's look at an example where multiple tasks would be there and there would be something called third-party processes which would be involved as well, all right? And if you're noticing, these third-party processes are separate from the JavaScript engine, all right? So let's take a look at a very simple example, but it uses all the pieces. So in our example over here, I have simple set timeout. It takes a function, it prints something inside timeout, and it runs after 1000 milliseconds. Then we have the printer function executed, and what does the printer function do? It simply prints out inside printer. And then we have console.log global, all right? So now let's say if I refresh my page, in what order do you think that this code is going to be executed? All right. Now, so far you should know that. So pause this video, really look at this, and you should be able to answer the question. There's nothing tricky over here. All right. So pause, come back, and let's go. So I'm going to refresh. And now you see over here that the inside printer got printed on line number 11 because it went over here and said, okay, I got to do this task. I'm going to do it after 1 second. So now go to line number 6. A new execution context is created for that. It goes over here and says, okay, I got to print this. So it prints this inside printer. And then once it's done, it resumes to the global context. It says, okay, I'm going to run line number 8 now. It prints global, which is printed over here. And then it says, okay, is 1 minute over yet? Oh, it is over. Oh, sorry, 1 second. And it says, okay, I'm going to run this function. This function is run after 1 second. And then inside timeout is printed over here. So far so good. Everything makes sense, all right? Now, one thing that I want to tell you that when you're using the set timeout feature of the JavaScript engine, this is actually a separate process called the timer process, which is separate from the JavaScript engine. So what's actually happening over here in this case is that when it's in our example, I'm going to zoom in over here again, and let's just delete other execution context. So the global execution context has this particular code. So it gets this and says, oh, I got to run some function in 1 second. Okay, I'm going to just, I'm not going to pause for 1 second. I'm not going to hold up my entire application. I will delegate this particular waiting behavior to the timer process. So it says, okay, hey, the execution context gives a message to the timer process and says, hey, remind me in 1 second to do something, okay? Just keep in mind, I'm gonna go ahead and do my other stuff. So you remember that JavaScript engine only does one thing at a time. It's single threaded. It only does one thread of work. So since it cannot do multiple threads of work, it just delegates that particular activity to another process, in this case, the timer process. So it says, okay, I don't have to do anything, so I'm gonna move on. It goes to the printer line number 6. It creates a new execution context, all right? And it says it does its job, it's deleted, or sorry, destroyed, and then it comes over here, it prints it, and that's it. The program ends. And you remember the task, there should be no task over here, right? So the first task already happened, which was the global execution context. So now the timer process is saying, hey, 1 second is over. So now I'm available. So it then gives a task to the message queue, and the message queue comes over here and says, okay, there's nothing in line. I'm the only process over here. So now I'm going to give this task over here. This becomes a new execution context. So there's no global anymore, right? So becomes a new execution context. And what is this execution context? It's simply a function, all right? And the function runs. Whatever is inside, it runs. And that's how the JavaScript engine works, the entire process works, and it is a loop. You see, any task that needs to be delegated to a third-party process comes from the call stack into the third-party process. Once the third-party process has something for us, It gives it to the message queue, and the message queue gives it to the call stack. So it's a cycle. And this cycle is actually called the event loop. And this is the way JavaScript is able to remain single-threaded while being very, very efficient and performant. That's why a lot of big companies use it. Now, JavaScript, the JavaScript ecosystem does not only have the timer process, it also has something called the DOM events, which we're going to learn about very, very soon in this course. It also has something called the HTTP process. So when you're making calls over the internet and the JavaScript engine is waiting for those calls to resolve and those messages to come back from the internet. So, JavaScript engine doesn't pause. It keeps on working on whatever task it needs to do. And once that message comes back, it goes to the message queue, and then it becomes an execution context, and whatever code needs to run runs. And that is the asynchronous nature of JavaScript while being single-threaded. So asynchronous means doing multiple things at a time, so not being in sync. So it's doing multiple things while delegating tasks to the third-party processes. So these are just 3 processes that are listed. There are many others out there as well. So that's pretty much it for this video. I know this is a very conceptual and theoretical, but this is going to become more and more important if you're going to take this profession seriously, and this could become an interview question as well. And this would help you become a better developer. That's pretty much it. I'm going to talk to you in the next video.